Want to review differentiation and integration, right? Right? So we're going to do them side by side, those system resources. Okay, I'm putting that there about 6. Yeah. Huh? Well, all right. Feeling right, then? Feeling right. But feeling wrong. Anyway, so today you want to review differentiation and integration, right? I'm doing them both together. What you have to remember in differentiation, what are the two things that we do in differentiation? We multiply and we minus, right? So we multiply and we minus. In that order, you multiply and then you minus. And integration, what you do? Add and then divide, right? So you see the reverse, right? It's the reverse, right? Nice. So let's start with a general example. If I gave you y is equal to 5x cubed, how do we differentiate? We write it as dy dx, or we can write it as y prime, right? And how do we differentiate? Bring down the power, write back the 5, and minus 1 from the power. So I multiply and a minus. So I'm going to get 15x squared. That's okay? That's how we differentiate. Right? If on the other hand now, I ask you to integrate 15x squared, integral is the opposite. So if I ask you to integrate this, you're going to add 1, integrate with respect to x. This tells us what the variable is, right? Right, so that'll be 15x. We're going to add 1 to the power and divide by that new power. Right, and always remember to add plus c. That's okay? 3 into 15 is 5, and we got 5x cubed plus c. We got back the answer, right? So always remember, if I differentiate something, I should be able to integrate and get it up. So look it up. Copy it down. Right? What you can do is do a table, right? Do a table. Keep everything side by side. But if you're that way to remember, right? When you see a differentiation question, what to do, right? The reason I'm trying to do two topics, these two at once, because in the exam, you're not going to see a differentiation alone, right? You're going to see a differentiation for number 4 and an integration for number 5. Okay, so you got to be able to do both of them at the same time. Copy it down. Right, let's go again. Right, so that's number one. Number two, let's try something similar and see if we can do it. Let's try 7x to the power of 4. Differentiate that. And I want you to integrate 28x cubed with respect to x. Right, to both of them, right? All right, time up. So we end up with dy dx being equal to, bring down the 4, write back the 7 minus 1 for the power. So that'll be 28x cubed. That's okay? Anybody get in trouble with us? No? And then integral here, 28, add 1 to the power, divide by the new power, and include a plus c because it's not definite, right? Point to that is 7x4 plus 6. Right? Here, we need to remember something. If I ask you to differentiate 5x, what's the differential of 5x? Just 5, right? You just technically drop off the x, right? So the integral of 5x is 5. Sorry, differential of 5x is 5. One more right here. What's the differential of 5? 0. Right? dy dx for 5 is 0. So whenever you differentiate something without a constant, without the x term, and constant, the differential is 0. That's okay? Yeah? So the differential of 5 is 0. Here now, if I ask you to integrate a constant, let's say 5, what you do? Just put back the x term, right? Just put back the x term. Right? And remember the reason why, right? 5 is the same as 5x to the power of 0. Anything to the power of 0 is 1. So this is the same as this. If I add 1 here, and I do the same thing here, I'll end up with this. All right? Okay. So I want you to remember that, right? Copy down those two little rules there. And let's combine them together now. Right, write down those two for loops, number 3 and 4, and number 3 then. Ready? Let's go. Right, so I want you to differentiate this, please. 5x squared minus 2x plus 2. I differentiate that. So you're applying all the rules that we just learned, right? Online, any issues, just stop me, right? Integrate that, differentiate that. Okay. That's here. Clear? Time. I differentiate the first one and integrate the next one. Remember to include the plus C, right? Ready? Let's go. So dy dx here is what? Right? 2 by 5 is 10 minus 1 from the power, you'll just get 1. The differential of minus 2x is minus 2. Differential of plus 2 is 0. That's okay? Yeah? As well, together. This one, add 1 to the power, you'll get cube, divide by that new power. Add 1 to the power here, you'll get squared, divide by that new power. And then add on the x here and your plus c. Simplify it a little bit. 3 and 3, that'll be 1 minus x cubed plus x plus c. Okay? Yeah? Right, let's make it a little bit harder now. So now that we remember how to differentiate, there's a next rule that we need to remember, right? if I give you something like this, 2x minus 1 all squared, you might be able to expand out the bracket and then differentiate, right? But suppose I give you the power a little bit higher, to be a little bit harder, right? So in a case like this, what you have to do is use the next method, right? There are two methods that we can use, right? For now, we'll just use the shortcut method. Anybody remember the two methods, the shortcut and what? Chain rule, right? And chain rule as well, right? But the shortcut is bring down the power, which is 5, right? Bring down the power, which is 5. Differentiate inside the bracket, which is 2. Write back the bracketed term and minus 1 for the power. So you'll get 10 by 2x minus 1 to the 4th. Watch it again, right? If you want to go by the steps in the summary, I have the steps listed out, right? Bring down the power, differentiate inside the bracket, write back the bracketed term and minus 1 for the power. That's okay? Yeah? So copy down number 6. Try number 7. Oh yeah, try number 6. Copy down number 6. Try number 7. Okay, let's be nice and anything. Eden, Aligancio, Elena, Sahara, you're getting through with us. Right, we're not doing any applications today, right? We just differentiate and integrate. Sahara, Eden, are you okay? Is your finish already? Number 7. Right, there is a version of this for integration as well, right? Integration don't have as much rules as differentiation. Well, in book 5. All right, let's see what you got. Right, guy along here, Isa. Yeah. But hurry up now.
Okay, so you're gonna put 3.
3, bring down the power, right?
Yeah, differentiate then say bracket, so you're gonna put 4.
Minus 4.
Yeah, minus 4.
So you get that wrong.
That we did.
And then what?
And then after I think I put back this same bracket.
Right.
Oh,
And I'll get 2. So
right, you can leave minus 12. And I think I put back the bracket.
all right. Okay. Nice. Right. What's the integration version now? If I ask you to integrate 2x minus 1 all to the 4th with respect to x, right? The integration version, similar to what you've been doing in integration, right? So you add 1 to the power, which is 5, divide by that new power, what? Let's do again. You have to differentiate the brackets and divide by it, right? So you have integration and differentiation here. Add 1 to the power, divide by the new power, and divide by the differential of 2x minus 1, which is 2. Right? I'm going to show you got time to go on the phone and things. Why was paying attention?
Yeah.
Right? Add 1 to the power, I get 5, divide by the new power, and divide by the differential bracket. So you will get 2x minus 1 to the power of 5, or you can write it like this, 1 and 10 by 2x minus 1 to the 5 plus 6. Okay, I just bring up the 1 and I just bring up 10. So I can write it like this as well. Okay. Try one here now. On the outside here, which way we would have 4. I'll let you remember what it is. I mean, keep it like this. Then you have it appointed like in case you have to use this again. Rather than 4. Do it like normal, just do it like normal. Right? For those who may remember whenever you do an integration, you could pull constants outside here. Right? So this 4, you don't have to leave it. You can leave it if you want, but you could also pull the 4 on the outside. So you can take the 4 and pull the 4 outside here and integrate this like normal. Right? And then I think it will cancel out. I'll cancel out, right? Work this out like normal. Work out this like normal, and then multiply it by 4. Multiply the whole thing by 4. Do it like normal. Do this just like how you do this. You understand that? And then multiply by 4. Now do one thing at a time. Finish. Right, so we just need to we can leave the 4 on the outside and integrate this, right? So that'll be 2 minus 3x, add 1 to the power, divide by the new power, and divide by the differential of here, which is minus 3. Put the plus c on the end. This 4 will cancel with this 4, and we'll be left with 2 minus 3x, all to the power 4 over minus 3 plus c. Right? If you want, you can pull out the minus 3 and get minus 1, 2. It's up to you. All you got this? Yeah? Okay, nice. Right? You know, we cannot do these questions and not get a square root, right? Differentiate that. Differentiate that and integrate this. Right? I know it might be hurting your brain to do both of them at the same time, huh? But integrated, differentiate. Differentiate the first one, integrate. What does square root mean again? To the power of a half. Nice one.
And the other part. The integration of the minor, yeah. What? I
No. I'll get you. So your first step is what? 2x minus 1 to the half, right? Now we're going to start to differentiate it. So, to differentiate this, bring down the power, differentiate inside the bracket, write back the bracketed term, and minus 1 from the power. A half into 2, that's 1. So you get 2x minus 1 to the minus a half, right? But you have to simplify that a little bit. The reason you have to do that, if they give you the question as a root, you have to get them back as a root. So what does minus mean? Minus in the indices means 1 over. Right? So minus in the indices means 1 over. Right? So suppose I had 4 here. Suppose I had 4 here. Right? 4 by this would have been 4 by this. So the 4 would have ended up on top. And yeah? So just remember those little things when you're simplifying, right? And give your final answer like this: 1 over the square root of 2x minus. Right? So I gave you the question as a root, give me back as a root. Okay? Fix that one for me now. If you could put it as a root. If you could. The questions online. Please remember that once you see this, minus and an indice, right, means that you can write that as a fraction, right? Ready? Same thing again, right? Same thing again, right? Whenever we integrate, we add 1 to the power. A half plus 1 is 3 on 2. We're going to divide by that new power, and we're going to multiply by the differential of this. The differential of 2x minus 1 is 2. 2 will cancel. Don't forget the plus c. So we're going to get 2x minus 1, 3 on 2. These 2's cancel, so I have 3 alone, right? So I can bring up the 3, and I will get 1/3. Right? But here's the problem, right? I want to write this back as a root. What does 3 on 2 mean again? 3 on 2 means a half by 3. A half by 3. Correct? So I can write this as 1/3. 2x minus 1 to the power of a half, all cubed. So I could write it as 1/3 by the square root of 2x minus 1. I could put the cube outside or inside here, but I'll put it outside, right? That's okay? Hi, do you put it bag? Huh? That's okay? So 3 on 2 can be broken up like this. Right? It can be broken up like this, or you can switch it around. You can cube this and put the half on the outside. Anyone you want. So you could also do it like this. Put the cube inside and put the half outside. So you can square root the whole thing cube. Right? I actually like that more. Right? So I just switch them around. That's okay? We have to learn to simplify square roots properly, right? Everybody okay with that? Online, any questions? Right. How are you going to differentiate this? How are we going to differentiate number one? Divide every term by x. Right? Or what the next method? Anybody remember? I didn't show you how to quotient rule, right? Right? Quotient rule. But here, I just want you to divide every term by x, then differentiate them. What about here? What you do here? Same thing, right? Divide every single term and then integrate them. Okay? Try that quick. Take your time, simplify the first one, differentiate, simplify the second, integrate. And please remember, it's every single term we divide by, right? Huh? Yeah, when you're done divide by x, then you differentiate. When you finish divide by x to the 5, then you integrate. Time simplify. Remember, when you divide in indices, what you do the power? Get minus, right? Go ahead, take your time, simplify, and then
Divide everything by x, y. Divide everything by x. Just according to the first one. Right, look at the powers minus them all. Don't forget the right plus C on the end, right? That was the methodology. Right, that's where it's from. Right. What is x cubed divided by x divided? That way, right, then 3x to the negative. It out and then, remember, only until you start to integrate, then you remove the sign, right? So, what the integral sign in front of it, inside the integrate, okay. Right, that's the integral sign. Right, and then you start to integrate up. Sorry, man. Sorry, man. That's cute. This is 3x cubed. Right, so y is equal to 3x squared, because x into x cubed is x squared, minus 4, we are splitting by. X into x squared is x into x is just 30. And then when we differentiate it, we're going to get 6x minus 4. Easy enough, right? And then with the integration now, we dividing each one, right? So you're going to get, I'm doing it step by step for you, right? I'm just breaking it up here for you. I am breaking it up here. Please do not remove the integral sign. You only remove it when you finish or when you start to integrate, right? Now, this will be x cubed divided by x5, x to the minus 2, x squared divided by x to the 5, x to the minus 3. Here, x divided x to the power 1 divided by x to the 5 is x to the minus 4. Right? When you reach here now we can start to integrate. So that'll be 3x, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, add 1 to the power, which is minus 3 over minus 3. Right? So this will be minus 3x to the minus 1 plus 2x to the minus 2 plus 13 on 3 x to the minus 3. When you reach here now, we can't leave it like this. Did I give you with minus indices? No. So you have to write it like this. Minus 3 on x, 2 on x squared, plus 13 on 3, plus 13 on 3, and I bring in the x cube underneath here, plus. That's okay? Final answer should look nice like that. Copy it down. Okay with that? Online? Everybody okay with it? See the way I simplify it out for you, right? Or if you get any habit of doing that, right? Right. I didn't bring it up here. I didn't bring it up here as yet, but what would happen if you see this? d2y dx squared. What does this mean? Differentiate again, right? So it means that you differentiate in the first differential. So you differentiate this and you'll get. That's okay? So if you see second differential, that's what it means, okay? Coming first, right? Just message the last two things coming first. Right? That is that. Right. I want to show you something in integration. Right, and I'm jumping into the rules here because otherwise we'll learn that for next week, right? We learn the rules, we do some hard ones next week, and then we start application. Okay? So make sure you know about the application. Everything is we do a syllabus already. Right after this, I want to give you a worksheet on the 3 topics that we did. Right? I want you to get used to reviewing more than one topic. By the next time, you're getting all the topics. Right. Just something I want to bring up here in integrals. I want to bring up definite integrals. I'm going on everything I feel like I spelling wrong. Is spelled correct?
No.
No?
E-F-I-N-E-T.
A?
Yes.
No, you was done.
No.
You are a little was done. Right? All right. So definite integrals, here's what we have to look at, right? Sometimes we're going to get questions that have numbers here, 4 and 1. Right? Whenever you see that, you're not writing plus C anymore, and you're going to get actual value. Okay? So whenever we integrate in something with limits, these are limits, right? The limits are called definite integrals, and in order to do this, right? In order to do this, we integrate first, add 1 to the power, divide by the new power, right? So we're going to get 4(1) of x cubed. We no longer write in plus C. Okay? What are you going to do now, Kai? With the 4 and the 1. Right? Substitute 4, and then substitute 1, and minus 7. That's okay? So you substitute the 4 in your answer, substitute the 1 in your answer, and work it out, right? People with the what is this again? 4Q is what? 64? And think so, right? Right. People with the Casios, you can put this in a calculator and you'll get it. Check and see.
That's it. But I put it up with X.
In exam, here, right? It have an X on the right hand side.
That's why.
What text do you use then? You got sure? Wait, what text do you use then?
This one. The alpha one.
Right, nice. So you can try that, right? Just to check the value. Right, try this one here now, please. Integrate between 1 and 0. Integrate 4x cubed minus 2. Integrate 4x cubed minus 2. Between 1 and 0. Right, online here, so I can just make sure that we can message your answers, please. Everybody, yeah? Everybody. Brianna send more messages online and when she in person. Brianna, you'll be distracted when you're in person. Very funny, so. Right, so she's here front. Hurry up. Message your answer online. Yeah, how about? Alright, another, yeah. Button online there. So, I'll just put them again. Alright, let's check out this one. This will be between 1 and 0, right? Because I integrated, I put a straight line, right? And that'll be what? 4x to the 4 and 4 minus 2x. This 4 will cancel, plug in 1 and plug in 0, you'll get 0, right? So I got 1 minus 2 is minus 1. That's okay? Checking the calculator as well, right? We just squeeze in one more. Yeah. Yep, sorry. Are there any something there? Next one, last one. Last one and we're done. Right? Very complicated. Integral between yeah, just giving us a little confusing values here. And then we do x squared over, let me see how you handle this. Right? Let me see it simplified, plug in your value. Right? Go ahead. Do you think that? No calculator for the first answer. That's a move down.
Allow this.
What? Right there.
Yeah, what do you like up there?
That's fast. That's fast. You can check it out. Hurry up. Hurry up, look it out, plug in your value 0 and minus. Your first step is the most important. How you write it before you integrate it. How you write it before you integrate it is the most important step. Okay, plug it in line. So you should have this, right? So you should have x squared, and if you write this properly, it will be 2x to the minus 3. Right? To the minus 3, because I bring up the x cubed. Okay? And then you integrate it fast and then plug in your values. About that's not. Right? So when you integrate, add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Plug in your 0, you know you're gonna get 0, right? And then plug in your minus 2. So that's minus 2 cubed on 3. This will become plus 2 will cancel, and you'll get 1 over this here, right? That's the same as x, 1 on x squared, right? So that'll be minus 2 squared. Right? We just have one slight problem. I left it out. There's 0 minus this. Because when you put 0 in here, that's the first value. And then when you plug minus 2, you'll get it. Much again. What you get? I have 813 plus a quarter. And then you finish up. Right, minus and a minus will give you a plus. Right, so again, the thing we were talking about last week, yeah, this is going to simplify properly, right? Right, using the rules. All right, that's it, copy it down, and that is it for today.